Hello guys, welcome back again in our interview series. Today is the second question that we have a topology here, the PC1 and PC2. There is two PC. We have basically there are two cases, case 1, case 2. Case 1 is PC1 have the IP address 192.168.1.1/29 and PC2 have the IP address 192.168.1.2/30. Question is both PC will communicate to each other or not. That means PC1 and PC2 will be able to make the communication to each other or not. In the second case is also there. In the second case also the PC1 have the same IP address and same subnet length. PC2 have the different IP but the subnet length is same. So again the question is in the which case PC1 and PC2 will communicate and in which case PC1 and PC2 will not be communicate. If they will not communicate, so where the packet will drop and which packet will drop, which traffic will drop on which location. Suppose we are initiating the ping command from PC1. So answer is guys, from the PC1, if we are going to use the ping command for 192.168.1.2, so answer is both will communicate. Because of, as you know, the PC, once you are going to use the ping command from PC1, then source IP will be there 192.168.1.1 and destination IP 192.168.1.2. So what the PC1 will do there now? PC1 will first perform the AND operation. It is going to match the how many bit? 29 bits. Which one is the common between both the PCs? Because of 24 bit or common, if you are going to write the last 8 bit, so 00001 here again, and we are matching exact how many bits? We are matching the 29 bits. So 29 bits you can see there the 29 bits are matching. First 24 bits are common and next 6 bits are also matching. So PC1 and PC2 both will communicate. Once it will send the ARP request and PC2 will send the ARP reply. In that ARP reply, the source IP again will be the change. Source IP will be there 192.168.1.2 and destination IP is 192.168.1.1. And in this case, PC2 is going to match the how many bit? It's going to match the 30 bits. So again 30 bits are also common. So they will able to make the communication. That is the case number 1. Doesn't matter they have a different subnet length, but they will communicate. Got it? Because of AND operation they are performing. So here the 29 bit are matching and here the 30 bit of matching. But if I am coming on the second case, case number 2, PC1 and PC2 are not going to make the communication to each other because of once you are going to use the ping command from PC1. So in this case, what will be the source IP? Source IP is 192.168.1.1. Destination IP is 192.168.1.5. So in the last octet we are going to convert into the binary. So this is the last octet 101. PC1 is going to match how many bit? 29 bit. Which one is matching? So it will send the ARP request. ARP request will receive by PC2. But once it is going to send the reply message, PC2 will match how many bit? It's going to match the complete 30 bit. The last bit is bit number 30 is not matching, so it will drop it. So that means in this case, ARP request will forward to the PC2, but PC2 will drop because of the IP address is not belong from the same subnet. So what is the final conclusion? Final conclusion is case 1 in the PC1 and PC2 will communicate. In the case number 2, PC1 and PC2 will not be able to communicate. Because of here the network ID, if you are going to check guys, 192.168.1.0/29 and here is the network ID 192.168.1.4/30. So case number 1 they will communicate and case number 2 they are not going to make the communication. Thank you guys.